Good evening, and welcome to a short tutorial on GR Level 3 and the accompanying icons that are included in the GR Level 3 program for all sorts of things, ranging from hail to TVSs, tornado vortex signatures, to wind gusts, to a bunch of things that we will cover both in looking at the user guide and at the actual icons themselves. And so in this short tutorial, I hope that this brings some clarification for you as you embark on your journey of discovering more of the features of GR Level 3 and how these icons can certainly greatly aid you in radar interpretation for Kent County SKYWARN. But in the event that you are not part of Kent County SKYWARN, perhaps you're in a surrounding county here in West Michigan, or maybe you are a weather enthusiast, or whatever the case may be, I hope that this information is helpful to you if you happen to use any of the Gibson Ridge or the GRLevelX products, the X simply standing for the different versions that have been released over the years. The icons have not changed a whole lot over the course of several years, even though sometimes they do vary slightly by edition and by the program as well. So tonight we're going to look at GR Level 3 specifically. We do also have GR2 Analyst that we will be looking at in the near future. I will quickly say on that, it has all of the features of GR Level 3 plus many more, and I personally hesitated for about 2 years as to whether to spend the $250 to purchase the one-time license, or rather the one-time purchase of the license, to be more exact. The license will work for as many installations as you want. But nevertheless, GR2 Analyst, especially version 3, was a phenomenal choice as soon as I purchased it. But that will be the topic of a different video, comparing and contrasting GR Level 3 and GR2 Analyst. So I have GR Level 3 currently pulled up, and at time of recording, it is approximately 0352 hours Zulu time or Universal time on January 29th, if we're going by UTC time. By local time, however, it's still January 28th, Saturday, close to 11 p.m. in the evening. And as you can see here on our radar program, looking at the left on reflectivity, we have an impressive snow band produced by an overall synoptic setup as a trough continues to produce convective snow along one of the post-frontal boundary layers here. And you can even see examples as I zoom in of some of the icons that GR Level 3 will include, such as this one. This 4.5-inch snow icon that indicates that a trained weather spotter at 3:31 UTC, which would be about 20 minutes ago at time of recording, at 2 South-Southwest Roosevelt Park in Muskegon, Michigan, reported measured snow of 4.5 inches. And if we are to quickly just look over in Milwaukee, Wisconsin, we can see that they have also received a decent amount of snow, such as just north of the radar site, a measured 4.0 inches. And to the east, we have closer to the lakeshore on the Milwaukee side, we have a measured 6 inches. And then even farther south, closer to the Wisconsin-Illinois border, we have a measured 8 inches by various trained spotters. Also some 6 inches as well too. So that is an example, a live example at time of recording, of some of the icons that we have. And this particular blue polygon, if you're curious what that is actually an outline of what's known as a place file for a Storm Prediction Center or an SPC mesoscale discussion, basically referring to all of the geographic areas in central lower Michigan, all of these counties, as well as, you can't see it currently with the overlay of reflectivity on radar, for all of the convective synoptic snow that will be developing in Milwaukee and the greater Grand Rapids, West Michigan area, the northern portion of the NWS Grand Rapids coverage area throughout the remainder of the evening until 10 p.m. So first things first, let's switch back here to our KGRR. That's simply the airport code here, which the radar adopts that airport code. Let's switch back to our radar imagery here for Grand Rapids. And obviously, if you have seen my previous radar videos, then you know that this product over here on the right is the velocity. Overall, winds are not all that impressive to speak about. Winds above 1,000 feet or around 20 miles per hour sustained, but they quickly drop off once you climb higher in elevation. So steady snowfall rates approaching 1 inch per hour, but nothing more than that. So we are currently under a winter storm warning, but we are not likely to see any more severe impacts beyond heavy snowfall. So as we go to GR level 3 and we click on the view menu, second from the edge here, just to the right of the file menu, we're going to scroll down in this menu and click on NMD Filter Settings. And I realize that those initials are very close in sound, so let me say it phonetically. The November Mike Delta, or the new mesocyclone detection filter settings. So let's go ahead and click on that. And we will see that I actually have already preset some of these settings, specifically in relationship to the max base and the minimum depth for the new mesoscale, or rather the new mesocyclone detection filter settings. And what this is designed to do is designed to eliminate false positives on radar. We'll cover this in a different time. GR2 analysts will show you this in much more detail, but it avoids the impacts of aliasing on radar when it comes to velocity. That will be the topic of another video. But nevertheless, our local NWS meteorologists have recommended to our SKYWARN team that we set the max base value in the NMD filter settings to 5 and the minimum depth value to 8, just to enable us to better interpret radar conditions so that the new mesocyclonic detection algorithm does not inadvertently generate false positives, or I will say as many false positives as it otherwise would. So make sure that you've got that setting. Just to quickly review, view NMD filter settings, make sure that max base is set to a value of 5 and minimum depth is set to a value of 8. And we will see why here as we now switch to our web browser and we pull up the GRLevel3 2.0 user guide, available at the following URL, grlevel.x.com/manuals/2/index.htm. Again, that's grlevelx.com/manuals/grlevel3_2/index.htm. And I'll make sure to include the URL and a link in the video description below. So in looking at the online user guide, it tells us information on how to get started in GR Level 3 that is certainly worth your time to read through, but nevertheless, if you've already watched some previous radar videos of mine, then you will already know much, if not all, of this information. But let's scroll down the page here and get to the storm attribute icons. Now, there are more icons in GR Level 3 that we will cover other than these 4 broad categories, but these would be the 4 most important categories pertaining to SKYWARN operations. So, to quote the online user manual, it states, quote, "Storm attributes are automatically downloaded and displayed on top of the radar data. There are tornado vortex signature, or TVS, icons, elevated TVS icons, or ETVS, new mesocyclone detection, NMD icons, legacy mesocyclone detection, or meso icons, and hail size icons," end quote. And again, that new mesocyclone detection, NMD, those were the settings that we adjusted just a moment ago to make sure that we get accurate interpretation, or more accurate, that is. It will never be fully accurate or match what a human can do in reading radar, but nevertheless get it more accurate, and it can certainly aid us as we understand severe weather. So, to begin with the first category of TVS icons, we can see here that the manual states, quote, "The TVS icon sheet has 2 rows of 10 icons. The icons represent the 10 digits of the TVS low-level delta velocity, abbreviated as LLDV, in knots. For example, the 19 icon indicates that LLDV, or low-level delta velocity, was at least 190 knots. So you have to ensure that as you read these TVS icons, such as this one, for example, if we were to look at a TVS icon, this upside down pink triangle with a white 2 embedded in the center of it, that is referring to a tornado vortex signature that has a low-level delta velocity of 20 knots. That in and of itself is certainly grounds for watching it, but not until we start getting into about these 3, 4, 5s, and again, powers of 10, 30, 40, 50 knots in terms of TVS icons, when the low-level delta velocity will start to indicate that a tornado is more and more likely to form. And we can see here the elevated TVS icon is simply a hollow pink triangle, an upside-down hollow pink triangle. Typically in my radar analysis, I don't generally see GRLevel3 generate that icon all that often. It will sometimes generate TVS icons for cells over mid-lake waters, and then typically, but not always, don't count on this as a rule, typically those icons will disappear once the radar is able to analyze the storms on a lower level. Again, we've talked about the various tilts and how that relates to elevation in one of my previous radar training videos, which I will link again in the description below. Moving on to NMD, again, NMD, November Mike Delta icons. These were, as we've mentioned already, the icons that we adjusted the max base and the minimum depth for already. And we can see that we have 2 rows and multiple columns of icons. So the top row, as we look at the description in the manual, is shown when the mesocyclone does not extend down to the lowest velocity tilt. So, for example, if GRLevel3 detects the presence of a mesocyclone, which is simply defined as a cell that has updraft helicity or rotation within the storm, what we would more commonly refer to as a supercell, if it does not detect that rotation down to the lowest velocity tilt, which would of course be a base velocity of 0.5 degrees, then you will see these hollow ring icons ranging in various colors which relate to the overall strength. So for example, we have sort of this pale green hollow ring followed by this lime green, followed by this yellow, by the red, and by the pink, or the strongest mesocyclone that would extend in the upper portions of a storm, but not yet extend down to the lowest base velocity tilt of 0.5 degrees. If, however, it does extend through all tilts of the radar beam, then we will see these arrows. And again, these are, if you know anything about the Coriolis effect and how weather patterns work, these are indicating cyclonic, or in other words, counterclockwise rotation. Counterclockwise rotation is known as cyclonic rotation in the northern hemisphere, and while you can get anticyclonic, in other words, clockwise rotation in certain cases, generally speaking, you don't see that often in the northern hemisphere. Because of the Coriolis effect and the rotation of the Earth, you will typically get anticyclonic or counterclockwise rotation in the southern hemisphere and not in northern latitudes. But again, there are exceptions to that, but that's a topic for another time. So these particular circular arrows here, this indicates the presence of a mesocyclone detected through all base velocity tilts and through all portions of the storm. So when we see that, we especially need to pay more careful attention. Now, I'll give a disclaimer, and I've used this analogy before, that this algorithm would be similar to a computer trying to decipher Morse code on its own. It works great when you've got a computer listening to another computer generating Morse code. But when you have a human, and when a human will just inevitably change the, on a millisecond level, the length of a dit or the length of a dot, or not necessarily always adhere to the textbook spacing between words, between sentences, and so forth, computers can get very confused very quickly. Generally, the NMD detection is more robust than that, but nevertheless, I have seen it generate false positives on radar in the middle of SKYWARN activation. So don't rely on that exclusively for letting you know the presence of a mesocyclone, but it is necessary. It is nevertheless a very handy feature that we shouldn't know how to avail ourselves of. So again, just as with the top row, we've got the corresponding colors. We've got this light green, lime green, yellow, red, and pink that indicate the relative strength of a mesocyclone as detected through the tilts of the radar beam. Legacy icons, which I have actually not yet seen in GR Level 3. The Meso icon sheet is shown on legacy volume scans. There are two icons, 2D detection and 3D detection, with the orange and the red solid circles respectively. I believe this would be for when you are studying radar data that is so old that it wouldn't necessarily indicate or generate to the algorithm the presence of a mesocyclone, but I'm not entirely certain on that other than to say I have never seen these legacy icons generated in GR Level 3. Now, another useful one that we also have are the hail icons. And the hail icons will vary not only in terms of their physical size, but you can also see the numbers embedded in them. And very simply, the size of the green triangles, which represent the estimated hail size within an updraft of a storm, these green triangles will change in size, and also the corresponding numbers in the middle will relate to the maximum diameter of estimated hail. And if you've taken any basic SKYWARN spotter training, you will know that hail 1 inch in diameter or above is considered severe. So this top row where we see these green hollow triangles, generally those will be generated for hail less than ½ an inch in diameter. This smaller solid green triangle, but that does not have a number within it, is going to be on average about ½ an inch up to an inch. But once we start to see hail icons of 1 inch or more, we really need to pay attention, because if a severe thunderstorm warning has yet to be issued and these start popping up on radar, it's typically the case that a severe thunderstorm warning will be issued for at least the possibility of severe hail. I will say the hail icons, in my opinion, are probably the most reliable that GR Level 3 in terms of its algorithms generates to aid you in interpreting radar data. Now, I will say that GR2 Analyst, when we look at volumetric analysis in the alpha tables, which I know sounds like a very nerdy mouthful, but that simply means that you can look at three-dimensional aspects of a storm in real time. That actually is far better at determining the presence of a hail core within a storm. But again, that will be a topic for a different day. But don't lose heart if you've got GR Level 3. These hail icons are generally very accurate. Obviously, it's still a computer at the end of the day using an algorithm to estimate it, and that must, of course, be verified through safe spotter operations. But nevertheless, I would encourage you to certainly pay attention when we see these hail icons, because they are some of the more accurate icons that GR Level 3 generates, in my opinion. So those cover the four broad categories, and you notice there's actually 5 here. I say 4 because, again, these old legacy meso icons I've never seen yet in GR Level 3, and I don't think that necessarily applies to NextRad 2 and 3 data that GR Level 3 is going to show you today. But I will say that these are not the only icons you will ever see, and there are icons that are not actually included in this online manual. So to see those, you actually have to navigate to the program directory, and if you don't know how to do that, no concern, you can simply follow along as I demonstrate here on the screen. But the program directory, if you are interested in looking at these yourself, is typically, again, this is a Windows 11 machine, but for Windows, the directory is going to be all the same, regardless if you're running 64-bit or 32-bit. It's going to be under C, Program Files, x86, GRLevelX, and then to go back, I'm currently in GR2 Analyst icons. Let's actually, if we can, go to GR Level 3. So let's pull up these icons here, and we'll just very quickly go through some of these. You can tell immediately by looking at some that these are just program icons as well. Some of these correspond to the toolbar icons, such as this one, Show Center, which I'll very quickly demonstrate. If you're not certain, and I know that I've pulled up GR2 Analyst here in this image, but it functionally will be the same as GR Level 3 for this example. If you're not certain exactly where you are or where the center of the radar image is, let's actually switch back to GR Level 3 because that will demonstrate it better for us. We can just go ahead and show the panel center, and we can immediately tell where the center of the image is. Do you often need to use that? Not especially, but sometimes it can be helpful to orient yourself if you need to try and orient the radar image back towards the radar site. Beyond that, you probably won't use it all that often. Again, we've got our show hail icon, show the LSR icons. We've got the melting layer. The melting layer will be a topic for another time. Show new mesocyclone detection, and then also storm tracks and the TVS icon. These program icons correspond to the toolbar icons that you will see here right underneath the menus in GRLevel3. Now, astute observers will notice that I actually, when I first pulled up the directory in File Explorer, will have noticed that I actually was looking at icons in the GR2 Analyst folder. And why was I doing that? Well, because these icons actually correspond to icons that you will also see in GRLevel3. So let's go back to icons, and we will go to, once I locate the correct directory, here we go. Let's go to IconSheets, and we can get a closer image of these hail icons. And I will move this over here into the window that I'm currently capturing for the recording. We'll go ahead and just blow these up a little bit more for easier viewing. Again, those are the hail icons that you can see. These ones are all possible icons that you may see both in GRLevel3 and in GR2 Analyst as well. These refer generally to different kinds of products out there. We'll just quickly go through some of them here. So this one up in the upper right, that's an avalanche icon. Probably never see that in West Michigan. If we do, we have much more significant problems than probably a severe thunderstorm going on. Not that that isn't a problem, but we also do have microburst icons here. We've got flood icons. We have a hurricane icon. Again, not likely going to see that in West Michigan, thankfully. Although there have been hurricanes that have gone as far north as Ohio before dissipating into general showers and thunderstorms, believe it or not. We've got different reported tornado icons here, such as this pink one. You will often see that icon when a reported tornado is on the ground. We will often see these rain icons as well too. These ones in the middle here from pink that darken to a reddish hue, those are for freezing rain, whereas these ones in green, that is for just traditional rain. These ones here, these gray icons with the forward pointing white arrows, those refer to wind gusts that are measured by various weather stations. And down at the bottom here, we can see our snow icons that I showed you earlier in real time. There were some snow icons being generated on radar. Again, the shade of these icons will change depending on the overall intensity of the measurement. And as we scroll through here, again, here's just another look at tornado vortex signatures. These ones in GR2 Analyst will look a little bit different than they do in GRLevel3, but nevertheless, the NMD icons, the mesocyclone icons, will look identical in both programs. So let's go ahead and close out of this here. And just to quickly review that we have covered everything, I'm just going to navigate through the directories one more time. Let's go back to GRLevel3. And let's go to IconSheets. Here's some more icons as well that we can look at. We've already looked at hail icons and the NMD icons. Let's pull the TVS icons up one more time just so we can get a little bit better view of them here. And again, they will be pixelated, but nevertheless, we've got our TVS icons reaching from 0 knots for the low-level delta velocity all the way up to 19 and 190 knots. If we were to see a tornado that had an LLDV value of 190 knots or above, that is an exceptionally bad day. That is a very historic day. and that is going to very likely involve FEMA and other organizations to try and remediate the effects from that. But nevertheless, let's go back to the LSR folder within the program directory. Here's some more, and these ones actually will show you what the icons are. So let's go ahead and we'll just click on this here, and we can tell based on the file name what it corresponds to. Again, pixelated because these are just small icons at the end of the day, but be able to see it a little bit better. As I stated, this is an avalanche icon. We've got a blizzard icon, which blizzards are not all that common here in West Michigan, but we have actually had one about a month ago at time of recording. We have a dense fog icon. We've got a downburst icon. We've got a drought icon. Typically, you're not going to see that issued. A dust storm icon, which is technically known in the weather field as a haboob. That is a type of storm that kicks up all sorts of dust and debris and generally can cause a lot of wind damage and especially a lot of breathing irritation, and also one of the more dangerous features of it is low visibility. Not whiteout conditions, but blackout conditions due to all the dust kicked up. Excessive heat warning icons with the red background and the white thermometer in the center. The extreme cold is the opposite, where we've got a purple background with a white thermometer. Extreme wind chill. Generally, again, these aren't issued all that often either, but nevertheless they can and have been for the Great Lakes region. Fatality icons. I have never seen fatalities reported in such a way in GR Level 3 that there are icons for them. But nevertheless, the icons are there. Flash flood icons. Again, these would be reported flash floods. Just a standard flood icon right there, the person submerged about knee-deep in water. There's a freeze icon, a blue background with a white thermometer. Again, freezing rain icons, and here you can actually see that it will tell you how much freezing rain has been reported. Anything above a quarter inch gets into ice storm warning territory. Anything below a quarter inch or 0.25 inches of accumulated ice accretions generally is going to cause pedestrian and vehicular problems, but is not considered severe. But anything generally above 0.25 inches or 1/4 inch of ice accretions generally will get you into the ice storm warning criteria. Funnel cloud icon. Hail icons, again, listing hail by various shades and sizes here. Heavy rain icons, these would just be traditional rain, not the freezing rain that we saw just a moment ago in terms of the icons. Heavy snow, again, these would be measured snowfall as reported by spotters or NWS offices or other verified accounts. High astronomical tide icons, we're not going to see that here with the Great Lakes because we don't have tides. High sustained winds. These are not wind gusts, these are high sustained winds ranging from less than 0 miles per hour. You're typically not going to see sustained winds reported above, generally, or rather below 40 miles per hour. Sometimes you'll see 35 miles per hour reported, but generally you'll most often see high sustained winds anywhere from 35 up to 95 miles per hour reported in GR Level 3. Hurricane icons. The ice storm icon, which would often go hand in hand with the freezing rain reports. Injury icons, not likely going to see those. Lightning, again, not likely going to see those. Marine hail icons, that would be relatively difficult to measure, and so you're generally not going to see marine hail icons, these lime green ranging from dark green with the corresponding diameter value in the center of the icon. Marine thunderstorm wind icons, again, same story as before, generally not likely going to see those. Here we've got non-thunderstorm wind damage reported. You will see these reported with often low cape, high shear events in West Michigan that aren't thunderstorms, but are nevertheless rain showers that mix those higher velocities down to the surface. Non-thunderstorm wind gusts, you will see these from time to time depending on the severity. These anywhere from light gray to darker gray icons with the L-shaped forward-pointing arrow with the numerical value in the center, such as anywhere from 5 miles per hour to 95 miles per hour. Rip currents, I've never seen those. You can have rip currents here on Lake Michigan, but I've never seen those icons issued. A Asish, that's an interesting weather phenomenon that is often associated with blizzard events near large bodies of water, such as if you are living in Buffalo, New York, on the shores of Lake Erie, which is notorious for those type of events. Sleet icons, these orange icons with the sleet you can see bouncing off the surface with the diameter, or rather the depth, the reported depth there in the icon window. Snow icons ranging from half an inch of snow to 35 plus inches of snow. The dark blue with the snowflake with the corresponding measured depth of snow. Storm surge, these would be pertaining to areas of the country that would encounter hurricanes. These lime green icons to darker green icons with the storm surge icon with the, I want to say that these correspond to feet, as it would not make sense for these to correspond to inches from 1 to 18 plus. I believe that would be feet of storm surge and not inch of storm surge. Tornado icon, pay attention to these because you will see these. These are often via reports from emergency management, law enforcement, sometimes members of the public, sometimes NWS employees or other certified meteorologists that work in broadcast media, and sometimes trained storm spotters such as SKYWARN spotters as well. Tropical storm icon, the difference between a tropical storm and a hurricane, if you don't know, is a topic for another day. Thunderstorm wind damage. You'll notice that the thunderstorm wind damage icon here, as we blow it up to make it a little bit easier viewing, has a green background rather than a gray background. The green background generated with the lightning icon indicates it is a thunderstorm wind gust, not a non-thunderstorm wind gust. So you will see those different icons populate depending on whether it's a thunderstorm wind gust icon or a non-thunderstorm wind gust icon. The colors will be different. Here we can see, again, we'll blow this up for easier visibility. We can see the yellow lightning icon with the various shades of green rectangles with the corresponding estimated or measured wind gust value produced by that convective system. And then they throw in a question mark unknown icon as well. And waterspout icons. Generally, you don't see waterspout icons appear on GR level 3, but sometimes you can if someone was there to actually report a tornado over water, which is the definition of a waterspout. Wildfire, not impossible in Michigan, but unlikely. And now we are back to avalanche. So that is a somewhat short introduction as I end here at just about 35 minutes of all of the various icons in GR Level 3. Again, just to very quickly as I wrap up, go back to the GRLevelX user manual. Again, I will post a link in the description. I would recommend you avail yourself of this user guide. And also, if you want to look at these icons in more detail, you can go to, I will link this directory that I'm navigating here in File Explorer below. It's located in your program files, and you can pull up all of the individual icons in GR Level 3 and look at them yourself. And I would encourage you to do that also just to get familiar. So with that, folks, I will see you next time for our shorter, I say shorter, simply because they're not hour to 90-minute or more training videos. But nevertheless, I will see you in our next training video as we continue to learn more about GR Level 3 for Kent County SKYWARN radar operations. So, 73 folks, and I will see you next time.